Welcome back to the Deep Dive. Today we are doing something that, frankly, feels a little bit illegal.
A little bit.
We're peeling back the wallpaper of the universe to see what's actually on the drywall underneath. And I have to warn you, if you're a fan of 20th century physics, you might want to sit down for this one.
It's definitely not for the faint of heart. We are looking at a stack of documents that detail a really heavy-hitting debate in theoretical physics.
It's not just formulas.
No, not at all. It's about the nature of reality itself. And honestly, it challenges the single most dominant narrative we've had for, what, over 100 years?
That's the thing that gets me. We're not talking about some fringe blog post here. We're looking at a debate between, the reigning champion, the Einstein camp, standard theory.
The stuff that runs our GPS.
Right. And the challenger. In the documents, this challenger is referred to as the E090, or the simultaneous point cloud camp.
Which is a mouthful, I know.
It is. But the core question they're asking is simple, even if the answer is completely brain-melting. They're asking, is the universe a simulation where time actually warps, or are we just looking at the data wrong?
That's the crux of it. It's the classic battle between what they call operationalism and realism.
Okay, before we dive into the specific paradoxes, we need to set the stage. Because everyone listening knows Einstein is, he's Einstein. Relativity is tested, it works. So what do you mean by operationalism? Why is that the standard view?
So Einstein's genius was in taking what we can measure and making that the definition of reality. Operationalism basically says, if you can't measure it, it doesn't exist in the theory.
Give me an example.
Okay, take time. If you're on a spaceship moving fast and I look at your clock and I see it ticking slower than mine, operationalism says time is ticking slower for you.
So there's no hidden clock somewhere else?
No. There's no real time. The measurement is the reality.
Right. And that's intuitive in a weird way. We trust our instruments. If the radar gun says the car is doing 90, it's doing 90.
Exactly. But here comes the challenger. The E090 camp is arguing for realism. They're saying, no, wait a minute. There is a true map of the universe, and it's distinct from what we see.
And what we call relativity is?
They claim it's basically an optical illusion caused by signal delays, not the universe actually bending.
See, that's where I get stuck.
Yeah.
It feels too simple. You're saying 100 years of physics just missed the fact that the light took a while to get here.
It sounds audacious, doesn't it? But what makes this so fascinating is that we're analyzing a series of audits. These are logical stress tests performed by AI models, ChatGPT, Claude, Gemini acting as independent space-time auditors.
This was the part that actually hooked me, because these AIs, they are trained on the textbooks. They know standard theory better than any human.
They do. And the logs show that initially these AIs were all in on Einstein, like 90% plus support.
Defending the status quo.
Totally. But then they were presented with these specific paradoxes from the E090 model, and you just see this massive shift in their logic.
It was like watching a witness crack on the stand. But let's back up. To understand why the AIs flipped, we have to get this map versus image thing. The documents mention a three worlds concept.
This is the foundation. The E090 model argues we are confusing three different layers of reality. First, you have world one, the mathematical world, or the map.
Okay, define that.
Think of a video game server, or a 3D coordinate system in a computer program. In this world, information is instantaneous. If I put a point at A and a point at B, the system knows where they are. Instantly. No lag.
Okay, so that's the absolute truth, the God view, essentially.
The God view, but we don't live there. We live in interaction with world two, the physical world, or the medium. This is where light travels. And the key, the absolute non-negotiable rule, is that light travels at a finite speed. See?
It doesn't teleport.
Right. Which leads us to world three.
The observation world.
Or the image. This is what an observer actually sees after the light reaches them. And the critique here is scathing. The argument is that Einstein confused world three, the image, with world one, the map.
Wait, I want to push back on this. We know light takes time to travel. Einstein knew that. That's why we look at stars and say we're looking into the past. How is this a critique?
Because Einstein took that delay and he baked it into the geometry of space itself. He said, because the signal is delayed and distorted, time itself must be different. The challenger says, no, you didn't need to bend the universe. You just needed to mathematically correct for the signal delay.
So they're claiming relativity is just a failure to calibrate our instruments.
Essentially, yes. And to prove it, the source material introduces a concept they call the boss.
The boss. Right. It sounds like a mob movie, but it's really an observational setup. The papers get into coordinates like z equals 100 in imaginary axes, which, makes my eyes glaze over.
Yeah, the math gets dense. Let's ditch the coordinates. Imagine a football stadium.
Okay, I'm there.
You're a player on the field. You're inside the universe. When the quarterback throws the ball, you see it travel. If you're far away, there's a tiny delay before the light of that action reaches you. Now, imagine the boss. The boss is a camera in a skybox directly above the center of the field, looking straight down. But here's the catch. The boss has a supercomputer.
And what's the computer doing?
It's running a protocol. Every time a light signal hits the camera, the computer calculates backwards. It says, okay, this signal arrived at 12:00.01. It came from 300,000 kilometers away. Light takes 1 second to travel that far. Therefore, the event actually happened at 12.00000.
So the boss is stripping away the latency.
Precisely. The boss calculates the start time by subtracting the travel time. And when you do this, the distortion of relativity just disappears. The documents call this restoring absolute simultaneity.
But wait, if you do that, doesn't that mean time isn't actually slowing down for the players on the field?
That is exactly what it means.
Yeah.
The source suggests that time dilation is just a lead angle issue. Like in a video game, you have to shoot where the target's going to be, right?
Right, deflection shooting.
The distortion isn't the target changing shape, it's just the geometry of the signal. The Chat argument is that Einstein was describing the math of the lead angle, but he thought he was describing the nature of the target itself.
Okay, that is a massive claim. But talk is cheap. The AIs, Claude, Gemini, they are programmed to reject this stuff. They wouldn't just accept a skybox analogy.
You're right. And the documents show the AIs pushing back hard. They kept citing Lorentz transformations and reference frames. So the challenges had to trap them. They used a thought experiment called the train and the sleepers.
This was the turning point in the logs. Set this up.
Okay, picture a train moving over a track. The track has railroad-tie sleepers. The train has a transparent floor and a little counter inside, a sensor. It counts how many sleepers pass underneath in exactly 20 seconds of internal train time.
Simple enough. Stopwatch starts, click, 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 stopwatch stops.
Now, we run two scenarios. Train A moves at a nice, slow, cruising speed. Train B moves at half the speed of light, super fast. In the same 20 seconds on their own clocks, Train B physically passes way more sleepers than Train A. That's indisputable.
Train B goes further, so it passes more ties.
But here's the problem. Standard relativity says motion is relative. It says you can't tell who is moving. Maybe the train is still and the track is moving backwards.
Right. From the train's perspective, the track is zooming by.
But look at the sleeper count. Train B's counter reads, say, 1 million. Train A's counter reads 10,000. That is a physical difference.
I see where you're going. Train B interacted with more stuff.
It's the energy argument. Train B physically experienced more bumps. It interacted with more of the electromagnetic field. You can't say the track is moving backwards because the track isn't burning fuel to hit the train is.
So there is an asymmetry.
A huge one. And this is where the AI, specifically Claude in the logs, started to glitch. The prompt asked, if motion is purely relative, explain the difference in energy consumption and physical interaction counts.
And what did it do?
It tried to say, well, from the train's perspective, the track contracted, so the sleepers got closer together.
That's the standard textbook answer, length contraction.
But the challenger replied, if the space shrank, did the total number of sleepers the train hit change?
No. You still hit the same number of ties, you just hit them faster.
Exactly. You can't perspective your way out of a collision. If you hit 1 million bumps, you hit 1 million bumps. The sleeper count proves that Train B has absolute motion against the medium. It knows it's moving faster.
Yeah, well, it's hard to argue with. It's like running in the rain. If I run faster, I get wetter. I can't claim the rain is just moving past me because I'm the one dealing with the impact.
Precisely. And once the AIs admitted that, the challengers dropped the hammer. They went after the weirdest part of relativity, length contraction.
This is the pancake proton scenario.
The pancake proton. In particle accelerators, protons move near light speed. Standard theory says they are Lorentz contracted, squashed into flat pancakes. Not just that they look flat, but that they are physically flat.
And the Chat prompt asked the AI a very specific, very dangerous question. Is the proton physically squashed, or just visually squashed?
It's a binary choice. If you say it's visually squashed, you admit Einstein was talking about an optical illusion, game over.
Yeah.
But if you say it's physically squashed, you run into the black hole paradox.
I need you to walk me through this slowly, because this feels like the checkmate.
Okay, let's use a marshmallow. Big, fluffy marshmallow. It has a certain mass, a certain volume, low density.
Tasty.
Low density.
Now, imagine you squeeze that marshmallow down to the size of a grain of sand. The mass is the same, but the volume is tiny. The density skyrockets.
Right. High density.
In physics, if density gets high enough, if you squeeze matter tight enough, it collapses into a black hole. That is a physical law.
Okay.
Now, apply relativity. If I run past a star at near light speed, relativity says the star shrinks in the direction of motion. It becomes a pancake. Its volume drops near zero.
So, the density goes to infinity.
Yes. And according to the math, that star should turn into a black hole. Wait, just because I ran past it?
That's the paradox. Does a star turn into a black hole just because you looked at it while running past it?
That sounds absurd. The star doesn't care about my perspective.
And if it turns into a black hole for you, it has to be a black hole for everyone. You can't have a star that is safe for one person and a singularity for another. That violates causality.
So how did the AIs handle this?
They tried. They tried to use relativistic mass arguments, but the logic just crumbled. Eventually, the AIs were forced to admit that the object cannot become a black hole just based on a viewpoint.
What do you mean?
Which means the contraction, the squashing, cannot be physical. It has to be an optical illusion, a projection effect. The proton, the star, they're still spheres. They just look like pancakes because of the signal lag.
That is a massive concession. I mean, huge. You're basically saying one of the pillars of relativity is just a misunderstanding of perspective.
It changes everything. It means the standard theory has been treating a matte projection error as a physical law for 100 years.
I'm still reeling from the black hole thing. It's so obvious when you say it out loud. Why hasn't this been solved before?
Because the math of relativity works for prediction. That's the trap. It predicts what the image will look like perfectly. It's like a funhouse mirror. If you have a perfect formula for how the mirror distorts your face, you can predict the reflection every time.
But if you start believing your face is actually shaped like a banana...
That's where you get into trouble.
So let's look at the scoreboard. We started with the AI supporting Einstein 96%. Where did they end up after all this?
After the audit prompts, the support shifted dramatically. Einstein's operationalism dropped, and Chat's realism rose to 90% in some of the logs. The AIs admitted the logic was more consistent, more transparent.
That is a wild swing. And there was one final analogy that seemed to seal the deal for them. The system architect.
Yeah, this is great. The source material stopped asking the AI to be a physicist and asked it to be a metaverse designer.
Okay, pretend you're building the Matrix.
Exactly. In a server, you have server time. That's the absolute tick of the CPU. That's Chat's math world. Then you have client lag. That's the delay users experience because of internet speed. That's Einstein's relativity.
Oh, wow. Put it that way, and it's obvious.
The AI admitted that while users experience relativity and lag, the server operates on absolute time. You wouldn't design a server where the CPU clock slows down just because a player has a bad connection.
No, you just say the player's lagging. You wouldn't rewrite the code of the game engine to say time has warped for user 452.
Exactly. And the source argues that telling people time slowed down when it was really just signal lag is, well, they use a pretty aggressive term.
Gaslighting.
Yeah, they call it scientific gaslighting, telling the observer that their distorted view is the only reality and denying the existence of the server just because you can't touch it.
That is heavy. I mean, I know how this sounds. We're sitting here talking about undoing the most famous equation in history. But the logic, the density argument, the server analogy,
right,
it sticks with you.
It does. And that's the goal of this deep dive. It's not to say Einstein was stupid. He was a genius who found a way to navigate the image. But maybe we've hit the limit of what we can do with the image.
So what does this all mean? If we step back, what is the Chat stance trying to tell us?
It's telling us that we live in a world with absolute time. That's the math world. But we view it through a slow medium light, which creates the observation world. The illusion of relativity comes from confusing the two.
It's like we've been trying to do geometry with a funhouse mirror and wondering why all the lines look curved.
That's a perfect analogy. And the source material leaves us with this really provocative thought. Physics has been trying to measure the ocean, the electromagnetic field using Galileo's old tools, and drowned.
Drowned in the math.
Maybe it's time to step outside the water, to the boss's position, to the skybox, and see the map for what it really is.
It's a call to change our perspective entirely, to stop looking from the inside out, and try to calculate from the outside in.
And honestly, even if you are a diehard Einstein supporter, you have to admit, the paradox of the black hole and the logic of the sleeper count forces you to ask a question. Are we measuring the universe, or are we just measuring the limitations of our own instruments?
A question that is definitely going to keep me up at night. That is all the time we have for today's deep dive into the architecture of reality.
It's been a trip.
Thanks for listening. We'll see you in the next one. Stay curious.